This is question 9, this time from the course note questions from Learning Outcome 4 of Engineering Dynamics. So in this question, we're presented with a fairground ride, which has a part of it where a carriage is suspended upside down as part of its motion. And we're asked to find the centrifugal force that's acting outwards, that's pushing the carriage against the rails in part A. And then we're asked in part B if the carriage will still have contact with the rails when it's at this point in the track. So let's tackle these one at a time. Question 9A is a problem where we're finding some centrifugal force. So again, we have our formula: force equals mass times omega squared times r. And we have some information in the question as well. The radius we're given is 10 meters from the center of the circle to the track. We're saying the height of the carriage is negligible here in this question. We use 10 meters as our radius. The mass is 500 kilograms, and the velocity, not omega, the velocity is 50 kilometers per hour. And there's two ways we can solve a question like this. We can use the formula we've been given. We can convert V into omega after converting it to meters per second, or we could use our other formula, F equals mv squared over r. We're not going to use that in this problem, but I want to just say that for people who do use that, this is a correct method, which would be assessed for full marks, but we're not using it in this particular problem. So let's convert 50 kilometers per hour into meters per second. So the conversion factor is to divide by 3.6. The reason for that is we're multiplying by 1,000 and then dividing by 3,600 to our 2-unit conversions. And this gives us 13.889 to 3 decimal places, and that's in meters per second. So omega is equal to V over R, which is equal to 13.889 divided by 10. And without a calculator, we can probably work this out as 1.3889 rads per second. So we now have everything we need to solve part A. Force is equal to mass times omega squared times the radius. Putting that into our calculator, we come out with an answer of 9645.062 newtons. And in the course notes, they just give the answer 9645, which I suppose is good enough in this sort of scale of answer. So that's part A, 9645 newtons. Part B of the question asks us, will the carriage still have contact with the rails? So we'll go over the question on our screen here and look at part B. Now what that is saying to us is, what extra force acting down is there that could be making the carriage fall? And it's a force of weight. The weight is given by mass times the gravitational acceleration. That is 9.81 meters per second squared. And that is just a constant, applies anywhere on the Earth and with any calculation involving the force due to the weight of an object. We've already said that the mass is 500 kilograms, that's given in the question. So we can calculate the weight. That's 500 times 9.81. And that is equal to 4,905 newtons. We've worked out the weight. But the final part here is to say, will the carriage have contact with the rails? Well, the answer is yes. F, our force acting up, minus weight, our force acting down, 9645 minus 4905. Well, we can see immediately that F is indeed bigger, but just to satisfy ourselves and to complete the calculation, make that subtraction, we'll find that the force pushing the track onto the rails is 4,740 newtons greater. So we can say, yes, this will be a safe roller coaster. The carriage will remain in contact with the rails during the ride. And that completes question 9.